Like most people who have been playing with electronics for any length of time, I've accumulated quite a number of bench supplies, and there's a whole range of different types. Some are very basic cheap supplies. I've got switching supplies, I've got a number of linear supplies, and again, like most people, I tend to have kind of go-to machines or instruments, usually because of where they are on the bench, depending on what I'm doing. And this is one of those types of machines. It's a Rigol DP832, and it's a triple output linear supply. It's not a huge output. It's 3 amps at 30 volts for 2 channels and 5 volt 3 amp for the other channel, but it is enough for most projects. So for perhaps 90% of my projects I have been using this. I bought this about 4 years ago, and when I first bought it, it had a fairly annoying fault every so often. Probably once a week it would reset itself for no apparent reason, and it was annoying, but just once a week I could live with it. But fairly recently it's becoming quite irritating, and the frequency with which it resets is rapidly increasing to the point where it now resets probably 50 times a day. And sometimes it will reset 2 or 3 times in a minute, and it's unusable as it is at the moment. It's just can't be used. There's no point setting it to run or try a project with it. It'll run for maybe a minute and then reset, and then I've got to reprogram it. You can program it to start up in a certain mode, but usually what I'm working on then needs resetting and restarting, and it's a real pain. And it shouldn't be doing it. It was an expensive supply, and these are still sold today, and looking around it appears this is a fairly common problem with them, and it has been going on now for a long time, and Rigol still don't seem to have really got on top of this, and they're not going back and addressing and putting right the units they've sold, which is, it's not really very good for a company like Rigol. I think this is extremely poor. It obviously hasn't been properly tested. And what I'm going to do in this video is have a look. I suspect it might be quite a difficult problem to resolve. A lot of people do seem to have had this issue, and Dave Jones flagged this up in a video quite some time ago, and it seemed to be caused by an overheating regulator, but I think other people have tried various fixes and it hasn't always worked, so it may not be as simple as that. But what I'm going to do is get this opened up. I've got the thermal camera on standby, so we'll have a look and see what that shows. But before I take this apart, I thought I'd just switch it on and let you see what the problem is, and hopefully you'll get some idea as to exactly what is going on, and what needs to be done to try and get it to work. So what I'll do, I'll turn this on. I'm not quite sure exactly how long it will take to reset. It does seem to be fairly random, so I may speed up the footage up to the point where it resets, but I will leave the camera running continuously until it does reset, so you get some idea as to exactly how long it takes, and I'll tell you how long it took to reset anyway. The randomness with which this occurs, it will run sometimes for maybe 10-15 minutes, and then other times within a minute it will just stop working. So we'll sit back, watch this. We'll fast forward this if it's going to take too long. One other point is we have this OTP, which I think is the over temperature protection, and I turn that off, but every time it does this reset, that is back on again. So something very bizarre going on, so I suspect it may well be something in firmware rather than just a simple hardware overheat fault. Also, the fact that it does it sometimes within a minute of switch on tends to indicate it's something else. We might have a problem with the raw supply capacitor or something that's not right, but I suspect it's a firmware issue. Okay, so as you can see, it's just reset. That was about a minute and a quarter. I haven't, as you can see, switched it on. It's not really powering anything, so it's not like it's going to get particularly hot inside. and that's not really long enough for anything to get significantly hot. The fan is running. The fact it's getting worse means that it could be a capacitor or something like that, or it may just be that the cooling channels are getting blocked up with dust or debris. I'm going to leave it running, see if it resets again, and at that point then we'll move on and get the cover off, have a look inside and try and figure out what's going on. Once again it's reset, so that was about another 2 minutes. So you can see this is way too regular now to for this supply to be usable. It's utterly pointless trying to use this. At the moment it's just a very expensive paperweight. So next step is we'll get it open up, try and do Rigol's job for them and see if we can't figure out how to get this supply to behave itself. So next step, let's get the case opened up. Okay, I've got the outer cover off. It doesn't look too dirty inside, it's a bit of dust. As I said, this is about 4 years old and it is used fairly extensively. It's not used all day every day, but it does get quite a bit of use. One thing I found was that one of the wires was trapped between the inner and outer case. It's been crushed and flattened. I can't see any sign that the insulation was penetrated, so I don't think that was shorting out. Just poor build quality. But looking around, I haven't turned this on with the cover removed yet, but if I pull these wires back, sitting under here is a bit of a horror show. You probably can't see it that clearly on camera, but this is the 5-volt regulator that Dave Jones showed as overheating, and there's very clear signs that this is getting extremely hot. This is kind of dark brown, looks almost burnt. There's no smell of burning, but looking at the two capacitors behind, it's possible that these are leaking. There's some burnt residue on the outside of them. So in terms of when this is switched on, this is actually outside the main airflow. It would sit somewhere kind of down here, and although there is a vent coming into the case, it's kind of outside of the main airflow. The main airflow is down the centre of the fan, of course, so there'll be very little airflow. It might even be stagnating airflow in this area, on top of which this is covered up by connectors and wires and the two capacitors themselves. This is an LM317, and as I say, I haven't tried measuring anything around it yet, but what we're going to do is turn the power on and see if that device is getting particularly hot. So we'll just turn this around a bit so we can get a decent view of it, get the thermal camera set up, or at least ready to look. Okay, so it hasn't been switched on yet, and nothing appears to be too hot, as you would expect. So we'll turn the power on, and it's powering up, and we'll see what happens. There's something getting hot there already. That's the sense resistor around that device. The crosshair on this camera is off a little bit. The peak reading is slightly below the crosshair, so we're now up around 34, 35. It's climbing extremely quickly. We'll look around the rest of the board. Look at the rest of the machine. So nothing else getting particularly warm. A few components getting slightly warm, but that one is obviously standing out, and we'll keep an eye on that. It's by far the hottest one. So we're now up getting towards 60 degrees. LM317, it's got thermal protection, so that cuts in when the chip temperature is around 130 degrees centigrade. But bear in mind that there is a thermal resistance between the actual chip and the case of the device, and that will be partially dependent on the current that is passing. So it'll be normally something around sort of the 10 to 15, maybe 20 degrees centigrade mark. So the actual internal device will be significantly hotter than we're seeing here, probably as much as 30 degrees if we take into account the fact we're looking at the heatsink. Let's turn the camera back on. Okay, so we're now up well over 80 degrees. Trying to find the hottest part is obviously going to be that heatsink. So about 82, 84, 86. So if we add 20 degrees to this, we're already well over 100 degrees centigrade for the internal temperature of that device. We're getting up towards 90 degrees. And of course this is made worse when the supply is supplying very light loads, because the fan on the power supply is temperature controlled. So when it's got very light loads, the fan will be turned right down. So chances are, if this is what's causing the problem, then the problem will seem to be lower when the supply is under high load. So we're now up over 95 degrees centigrade. That's putting the chip temperature probably up towards 130. So we're getting pretty close here to the point where that is going to go into thermal protection. Just hunting around for the hottest part of it. So I'm seeing temperatures over 100 degrees here, and that does mean that we are very close to the thermal shutdown of that unit. I don't know what it's supplying. Okay, so it's now at the point where we're in the area that it could reset at any time. On top of this, we've got these capacitors here that are almost certainly cooked. And what I'm going to do, it hasn't reset yet, which is odd. Normally for the last few weeks it's reset within the first few minutes. So it may well be that having it open like this is helping it rather than hindering, as we would expect it to with it not being in its enclosure. What I'm going to do, I'm going to turn it back off, and I'm going to temporarily solder some wires to the 5-volt rail, and we'll hook this up to a scope, get it to trigger if the voltage dips, and then we'll leave it running and see if we can capture anything. So I'll get that set up, get back on camera, and we'll get that test underway. Okay, the setup I've got now is I've got the power supply hooked up. I've got a couple of wires soldered onto the board, one soldered directly to the logic 0 volt, and the other is connected to the 5-volt output of this regulator. I can confirm that if this 5-volt rail is pulled low, then it does cause the supply to reset in exactly the way that we've been seeing. It is quite cold in here this morning. As I say, there are extractors run overnight that are kind of up there out of sight of the camera, so it does get quite cold in here. So I've got those turned off at the moment. I don't want them pulling air across this while we're carrying out this test. The scope is connected across the 5-volt supply. We'll just turn the second channel off. So the trigger's set to just under 5 volts, so with a falling edge. So if the 5-volt rail does dip, it should trigger the scope. So I'll turn the supply on. I'm quite sure if you can quite see the display on the supply. We can see that we're getting a DC voltage on the scope. I'm going to set the scope for single trigger, and if that voltage does dip, hopefully we'll capture it. It may well be that there's a kind of a supply monitor or watchdog on the system somewhere, and if it sees a brownout situation, it resets the processor. Or it might even be the processor itself has internal brownout protection, and it might not be that the voltage is going off completely, but we'll keep an eye on it. That device does have, the regulator does have thermal protection, and it does switch off its output if the temperature goes too high. and as we've seen, we are getting extremely close to that temperature, so chances are that's what's going on, but we'll keep an eye on it and see if we can capture something definitive before we start making any modifications. Okay, well, the supply has just reset, but the scope wasn't triggered, so it does not look like that device actually caused the reset. Now, it is possible that the voltage has dipped too low. I'm just going to start the scope running. So we're only about probably 300 millivolts below the current value, so if the regulator had reset, almost certainly we should have seen it. Let's slow this down a little bit. The regulator is up about 107 degrees, so it's very close to the threshold, but as I say, it didn't seem to go into shutdown. Now, the fan is momentarily increasing speed. It does that shortly before the reset, so it's possible there's another factor here that's going on. I'm not quite sure where the sensor is for the overheat, and what I need to do is have a closer look round, see if I can find anything. Either way, this does need to be sorted out. It could even be that it's the capacitors starting to fail that are close to that device. They are well outside their rating almost continuously, and looking through the thermal camera, they are starting to heat up as well, so I suspect once this has been on for several hours, they'll be just being roasted by that regulator. It's actually very poor thermal design on this. It's kind of a bit disappointing considering how expensive these are. The other thing to bear in mind, of course, is that when this is assembled, this large heatsink on this board, along with this one, will be largely blocking airflow going across that device, so it may well be this gets even hotter when it's in the case rather than colder. I may well attach a thermocouple to that at some point and monitor it while the case is closed. But either way, it's odd that we didn't see anything on this line, and it's possible this was a function of the capacitors being there, of course, and it just dipped low enough to cause the reset without triggering the scope. So I'm going to leave it running and see if I can see anything on the scope next time it resets. Then we'll get back on camera and start looking at taking the board out and correcting this and getting a better heatsink on there, and then repeating the test and see if we've improved things at all. Okay, I've had the supply running for a while now, and it is resetting on a fairly regular basis. The temperature of that device is now up over 120 degrees. Let's try and find the hotspot. It's at the wrong angle really for the camera, but if I get it in the right place, it's showing me a temperature of around 120 degrees centigrade, and that's the heat sink. So chances are that the internal temperature of that device is right at, it's just sitting at the point where it's trying to reset. I'm not seeing anything on the scope when it does reset, but the other thing I've noticed is that if I do move these wires around, you can often provoke it into doing a reset. I'm not quite sure whether it's a combination of moving them or a particular wire, but by moving them around, it will sometimes, or quite frequently, prompt the supply to do a reset, and it seems to be doing it less frequently the more I do this. So it could be we've got a bit of corrosion or something on one of these connectors, or it's not very well crimped. But either way, what I'm going to do, I'm going to take this board out and have a look on the back side of it and see if we've got any poor connections there. I'm going to look at all the joints. It's just done it now when I move this wire. So when I move this wire, it resets, and this is the 5-volt output from this board that comes from that regulator. So it might just be that we've got poor crimping on some of these connections. But either way, I'll take the board out and inspect it. I need to put a larger heatsink on this device. I'm going to replace the device anyway. If it's been running that hot for that long, then most certainly it's getting towards the end of its life. And I'll replace the 2 capacitors as well. They're almost certainly toast at this point. And I may well solder the wires onto these crimp terminals, clean up all the connections, and we'll then do a retest and see if it behaves itself. So here's a closer look at this device. You can see it's badly discoloured, and we've got this weird residue on the capacitors at the back. I'm not really sure what's going on there, but what I'm going to do is I'm going to take these capacitors out and test them off the board and see if they've become leaky or maybe just lost capacitance. And I'm going to replace this device. It's been running extremely hot for a long time, so it's probably going to fail fairly soon, and then I'll come up with a better heatsink arrangement than this. It's way too small. The voltage going into it's around 12 volts. They've got fairly high mains here, and this is a linear supply, remember, so the raw voltages, the raw DC voltages, will be affected by the incoming mains voltage. And so we've got 12 volts going into this, 5 volts coming out, and judging by the temperature rise, it's passing around just under an amp, I think. And this heatsink's way too small. Now it's, I think, intended or assumed to be running in an airflow, but I don't think the airflow is that great at this point, looking at the way it's arranged. The vent is on this side, so it's the capacitors are in the way, and although that will protect the capacitors to a certain extent, it allows the device to get extremely hot. Having said that, when the supply was resetting, I saw no evidence that the 5-volt rail was dipping or this device was shutting down, so it may well be this is completely unrelated, but either way it's something that needs to be sorted out before we do anything else. Also on this board, notice on the underside, extremely dirty. It doesn't appear to have been flux washed, which is a bit odd, but yeah, it's I'm a bit disappointed. It's an expensive supply, and I think they've kind of missed the point somewhere along the line here with regard to the thermal design. It's not very good, and this is real amateur hour stuff in this corner, so I don't know who is responsible for that, but I think they need to review their work and maybe come up with something a lot better than this. Okay, well, I'm going to get on with this and get this modified, get the capacitors checked. If I do find anything, I'll obviously let you know. Okay, I've removed the 2 capacitors from the board, and I can't get a sensible reading out of either of them. I've tried all sorts of different meters, but I get all sorts of weird and wonderful readings from them, but they're clearly not healthy, and I think they're just extremely leaky. I'll do a proper leakage test on them another time, but certainly as they are not really usable. So looking at them more closely, there is a definite dark patch on them. I haven't seen that before, and it's on both of them, and it's kind of strange. So I suspect we've got a hot spot in that location caused by the overheating regulator. And I left it running like this for a while when it was all connected up, and the heatsink does get up to around 125 centigrade. That's the heatsink temperature, so the internal temperature must be much higher. Now we didn't see anything on the scope, so it's a bit odd that it's not shutting down, because it should do at that temperature. and it is still highly possible that the fault lies elsewhere. I also found quite a lot of dirt and a coating of corrosion on some of these pins, so that may well have something to do with it. The connectors as well have quite a lot of build-up inside them, and looking down the end of this, the negative terminal definitely is not crimped very well. I don't know if you can see, but it's not crimped at the back end at all, so it's not crimped into the wire. So it's actually wrong size wire for these crimped terminals, so I'll probably pop these out and actually solder them to the terminals just to make sure, and I'll probably do that to all the rest as well, and we'll see if that gets us anywhere. It is odd that the way they've routed all the leads, they're all kind of bundled together, the AC and the DC leads, and also we have this unscreened lead. Now I'm sure they've done testing on this and it's worked, but I may well put a bit of screening on this just to try and protect it a little bit. And obviously I'll replace the regulator, put a bigger heat sink on. Luckily there is plenty of space here. There's no tracks in this area, so I can put a much bigger heat sink on this particular regulator. And I've checked in the case as well, there's nothing else in the way, so it doesn't matter if something else extends down into this area, it will still go into the enclosure and it won't foul anything. So I've just now got to wait for the replacement parts to come in, and so in the next video in this particular mini series we'll start reassembling this, making some modifications, and then we'll put it back on test and see if we're getting any nearer to a solution.